the if-then-else conditional expression can be processed using the case syntax in SQL. One thing to note is that the case syntax may not be available in every version of SQL, as it is not available to versions that only comply with the older standards of SQL. Technically, the case expression can be used in the select, where, and order by clauses in the select statement, and can also be used in the update and the delete statement as well. But most commonly it is used in the select clause of the select statement. So here's the syntax for the case expression, and you can use a series of when followed by an expression that states a condition, and then followed by an expression that shows the action if the condition is met, to show different treatments for different situations. The case statement ends with an else statement, which shows if none of the previously stated conditions are met, right, what would happen. Right, so for example, let's say I have a case statement that looks like this. Select case when product line equal to 1, then product description. Else, single quote for pound signs. Okay. And end as product description. From product table. Okay, let's take a look at this statement and see what it means. This statement would display the product description for all the products that belong to product line 1 only, and then display 4 pound signs for all other products that do not belong to product 1. So as you can see, the case statement is put into the select clause of the select statement here, right? Because depends on whether the product belongs to product line 1 or not, we are going to either display the product description field or simply display the 4 pound signs, right? So the end as product description clause here is referred to as case name, and it is an optional parameter and indicates that the column will be called product underscore description when it is used in the query. Right. So as you can see, this is embedding the case expression within the select clause of the select statement to determine what information will be displayed when the query is executed based on the content of the database. Right. So as you can see, it's a very versatile statement that allows you to display information based on whether the record meets a certain condition or not. While in most cases, commercial computer systems and software products are relatively reliable, there can still be hardware, software malfunctions or human errors once in a while that may corrupt the data in the database system. This is especially problematic if the computer malfunction happens in the middle of a series of database operations. For example, if a database system is in the middle of executing a series of insert statements or update statements to update the data in the database, any interruption during that process would result in only part of the database being updated and eventually inconsistency in the data. In another situation, if the hardware fails in the middle of a routine database backup, then only part of the database is backed up by the system. Right? To avoid these situations, data maintenance is defined in units of work called transactions, which involves one or more data manipulation commands. So in order to maintain data integrity, the rule for a transaction is that all the commands in the transaction must be completed by the database systems, or none of them will be completed. So this is a very important rule, especially in an e-commerce scenario. For example, if you have placed an order for 5 different products on Amazon, when you confirm the order, a series of database actions will be performed. Right? An order will be created in the database, 5 line items will be inserted into the order line table, the inventory levels of the products will be adjusted, and so on. Right? So all of these operations are part of this one transaction of confirming your order. Right? So if the system encounters an unexpected interruption during the process of performing these operations, then data inconsistency would happen, right? And your order would not be recorded correctly. So therefore, it is important to have all or nothing at all when processing a transaction. So to facilitate transactions, SQL allows you to define a transaction using the begin transaction and end transaction commands. These two commands would mark the boundaries of a transaction. So all the SQL commands involved in that transaction will be placed between the begin transaction and end transaction commands. This way, if the system interruption is experienced, the database management system would roll back all the changes that have been processed in the transaction so that the database was restored to its original state. The transaction can be reprocessed after the system is stable again. In addition, a number of SQL statements can be used to commit changes to the database or roll back the changes if you want. The command commit would make all updates permanent when it is executed. In fact, in most database management systems, you can set the auto commit option to on so that all commands are committed automatically when they are being executed. However, if the commands are not committed, then you have the option to roll back the operations. The command rollback would allow you to cancel the updates since the last commit command was executed. So as you can see, you have a few different commands that would give you the flexibility to make the changes permanent and cancel some of the operations to the database. This example demonstrates how a SQL transaction works. Within this transaction block, we have a series of insert statements that insert new records into various tables. Suppose there is a problem with the transaction. For example, for some reason, maybe a software error or human error, an invalid product ID is entered in these commands. This would result in an error for some of the commands and cause the transaction to be stopped in the middle. So when that happens, since all commands are considered one transaction, the database management system would roll back all the commands that have already been executed in this transaction to return the database state to what was before the transaction began, and then awaits instruction from the user again. So as this example shows, the transaction command allows the database management system to maintain data integrity and avoid any issues that may be caused by system or human errors. While most of the time, users of databases only need to access database tables that contain the data that are relevant to the operations of the business. The database management system also stores system tables that contain the metadata or the data dictionary of the database that can be accessed by either the users or the database administrators. So for obvious security reasons, the database administrators can determine user privileges when it comes to accessing these system data or system tables. And in pretty much all cases, users are restricted from updating these tables to prevent accidental or intentional corruptions to the system tables, so that users usually only have the privilege to view these tables, but restricted from updating these tables. As you can see in this slide, different database management systems would have different system tables and name the same system tables using different names. For example, the system table that describes the content of the database tables in Oracle database management systems is named the DBA underscore tables, whereas in the SQL Server database management system, a similar system table is named the sys columns table. Right? While the table names are database management system dependent, the purposes and the use of the system tables are very similar across various database management systems. You can use the select statement to access data from these tables. So for example, to identify the owner of certain database tables in Oracle, you can issue a statement like this: select owner, which is one of the fields of the DBA underscore tables, right? And the table name, which is another field in that table, right? From DBA underscore tables, which is the name of the system table. And if you're looking for the owner of a particular table, you can put in the where clause, where the table underscore name equal to, let's say, for example, the product table. Right. And this is going to return the name of the owner of this particular table. So having access to the system tables is obviously critical to database administrators, which we will discuss in a later module, but also for users if you're interested in finding out the types of data and their access methods in the database, understanding the system tables would be quite useful. This slide shows a few examples of enhancements and extensions to the traditional SQL standard that were defined in SQL 2008 standard. These enhancements are mainly designed to improve the flexibility of SQL in application development, transaction support, analytics applications, and moving to a more object-oriented programming style for SQL. For example, users can now define data types by making it a subclass of a standard data type or creating a new data type that behaves like an object that comes with defined functions and methods. Traditionally, analytical functions are embedded in the application programs that access databases, but a set of analytical functions have been added to the 2008 SQL standard, such as ceiling, floor, square root, rank, and the rollup for creating subtotals. In addition, the window clause allows a query to specify a database action that can be applied to multiple rows called window. A number of new data types have been included, such as big integer, multiset for tables with duplicate values, and XML for the XML file type. These new data types are especially useful in today's big data environment. The new create table like command allows one to create a new table that is similar to an existing table, which would reduce programming needs. And the merge statement that we discussed before allows the master data file to be updated without compromising its integrity. So as you can see, this just shows some of the enhancements and extensions of the new SQL standard that happened more recently. In addition, efforts have been made to make SQL to behave more like a full-featured programming language in the newer standard. SQL can now support a wide range of decision and repetition operations as seen in other programming languages. Various database vendors have developed their own flavor of SQL programming languages. For example, Oracle's proprietary version of the SQL language is called PL SQL, whereas Microsoft's SQL Server's version of SQL language is called Transact SQL. And they differ slightly in syntax, but are very similar in their functionalities and the programming logic. So if you learn one of these versions, you will be able to transfer your knowledge to other versions of the SQL programming languages pretty easily. For users and administrators of databases, the key programming enhancements in SQL are routines and triggers that reside in the database management systems instead of in the application programs. Both triggers and the routines consist of blocks of procedural code in SQL that can be executed by the database management system. Routine must be called to be executed on demand. In contrast, triggers are executed in response to a database event such as insert, update, or delete. And then within routines, there are two types of routines, functions and procedures, as with any other programming languages. If you have taken a programming class, you would be familiar with these concepts. Functions are routines that return values and take input parameters. For example, a function such as month can be a small program that would extract the month value out of a date when it is being called. It takes the entire date value as the input parameter, which usually enclosed within a set of parentheses, right? And then return the month value, such as whether it's January or February, or in numeric formats like 1 or 2 and so on, right, as the result. A procedure is simply a piece of programming code that, when it's called, does not return a value but performs an action. For example, you can create a procedure called sort, right, which would sort the data when it's being called. This diagram illustrates the differences between routines and triggers. As you can see, both are blocks of program codes that perform a certain operation on the data from the database, so they interact directly with the database. But procedures are called by users or programs explicitly to be executed. Right. In contrast, triggers are executed automatically when update, insert, or delete command is executed. So they are what's called event-driven. This slide shows the syntax for the create trigger, create procedure, and the create function commands. Writing routines and the triggers is beyond the scope of this course and will be covered in a more advanced course on SQL. But you probably need to know how to call a procedure as a user of the database system. So to call a procedure, the user simply uses the execute or exec command followed by the name of the procedure and any parameters that need to be supplied. Right? The functions is simply called by stating the function name and any input parameters that need to be supplied to the function. The advantages of having routines and triggers as part of the database management system are efficiency and shareability. They are more efficient because they can be optimized for the specific database, and they are shareable because any application program that accesses the database can access these routines and triggers. However, when the programming component cannot be part of the database management system, then we can embed the SQL statements in the code of the application program. Most programming languages today support embedding SQL statements in the program code for accessing databases. This option gives application programmers a lot more flexibility and control over how to access and use the database. In most application programs today, embedded SQL statements are what we call dynamic SQL statements, which are SQL statements that are generated on the fly. For example, when you shop on Amazon and search for a textbook, Amazon website would return a list of books that meet your search criteria from the database. So those pages are dynamically generated by the application program, as Amazon would have no idea beforehand what you were going to search for. Right? The SQL statements executed in those cases are generated on the fly based on your user input. For example, the dynamic SQL statements in an application program may look like this. Data source equal to company DB, name equal to get products, and then followed by the SQL statement, select everything asterisk from product table where the product description, like using a wildcard percentage sign, which means any collection of characters, and the URL dot product description, and the pound sign and the percentage sign. All right. So as you can see, in this example, the data source defines the name of the database to be accessed by the code, and the name get products creates a container where the query results will be stored. The SQL statement provides a general syntax for querying the database, but the condition, as you can see, is generated on the fly by supplying the SQL statement with what is called a URL variable, which includes the criteria user provided in the form in a previous search web page and is passed onto this piece of code as part of the URL. As you can see, the SQL statement will be generated based on whatever the user entered as search criteria. So that is an example of dynamic SQL. And this example here applies to an e-commerce application obviously, because of the URL variable, and different programming languages will have different syntax for creating dynamic SQL statements. Finally, another concept to understand is the differences between SQL for online transaction processing, or OLTP, and SQL for online analytical processing, or OLAP. Traditionally, enterprise databases were created to support the operations of the business. Therefore, they are considered online transaction processing systems. During the past decade, analytics has become a critical part of strategic information systems of many organizations, and that has caused many online analytical processing systems to emerge. Online transaction processing systems tend to focus on computational efficiency and accuracy, as a company may process millions of transactions each day and needs timely and precise execution in order to make its customers happy. Therefore, SQL statements written for the OLTP systems should be small in size, involves less data sources, and uses simple and standard queries that can be executed quickly across many computer platforms. In addition, it needs to support multiple users who are accessing the same data simultaneously and avoid any data integrity issues through careful normalization of the database. However, in an online analytical processing environment, the objectives are a little different. The objectives of an online analytical processing system is to provide users with flexible views of the data from many different perspectives to support all types of decision making. The data retrieved tend to be large in volume from many different data sources, and the queries tend to be very complex to represent the multidimensional nature of the enterprise data warehouse. And the data are less normalized in order to handle large data more efficiently. And at the same time, the systems are accessed only by a handful of users who can have these unobstructed views of the enterprise data, although this may be changing as the practice of data analytics becomes more prevalent among middle managers today. Finally, it offers data in a format that can be processed by various visual and statistical packages for more in-depth analysis. So due to the differences between these two types of systems, SQL programs developed for them also need to be designed differently in order to maximize their effectiveness for their intended business use scenarios. So this concludes our discussion on an important database topic, structured query language, or SQL. As I mentioned before, there are a lot more to SQL than what is covered in this textbook and this course. You will get some hands-on experience with SQL by going over the tutorials and exercises I have provided in this course, and those should give you a very good foundation for expanding your working knowledge on SQL in the future, if data management and analytics is the field that you would like to pursue.